Hey everybody, in this video we're going to talk about section 3.3 and solve some examples. Of course you want to go into your lecture and read the textbook and all the notes before you attempt some of the examples, and these videos are of course a style of kind of a hybrid between giving a lecture and a review or reinforcement. And there are some details you will find in the book if you need to graph the region for these linear programming. And here the fundamental theorem of linear programming is for the maximum or minimum you'll be interested to maximize or minimize the value of the objective function is achieved at one of the vertices or you're going to look for a vertex of the feasible set, and that kind of region we're talking about is the feasible set. A first example, a simple one. Let's say you have a feasible set here and you have these vertices and you're interested in finding the values of x and y that maximizes the objective function. And think about this objective function, whatever application it is. So one thing we can do is do a table and try these, so for practice, I'll just show you. I'll go through all of them, or this one. 0, 0, that's 0, right? 0, 5, so we're using the objective function. So 0 plus 3 times 5, that's 15. And this one here is 6 plus 3 times 0 is a 6, right? And this one here is 4 plus 3 times 2. A 6 and a 10. And since we're looking for the maximum, 15, 10, 6, and 0 there. But 15 is the winner, is where the maximum is. And if that's the case, then x is 0 and y is 5. So this is kind of the idea. You'll be looking for a feasible set. You can graph it from, if you watch the previous video, you'll figure out how to graph these feasible set. And once you graph it and you start having kind of these edges and these vertices, then you will find the values and compare. Here is an example of an application, and we have the graph, and the earnings are 50x plus 40y. And so, of course, this is 0, 0. And if we put 0, 0 there is 0. So just ignore that one for now. And for this function, I'm going to show you kind of going right to it way is if we look for this, let's call it vertex. So this y equal negative x plus 250, this is the y-intercept, right? If this is y-intercept, means x is 0. And when x is 0, this is a 250, okay? And here we have an x, but y is 0. But for this here, y equal negative 2x plus 400, and 0 equal negative 2x plus 400. So we subtract 400, we get negative 400 and divide by negative 2, and we get x is 200. We have this one remaining. That must satisfy these two. This number 1 here and this number 2. So if it satisfies these two as we did in previous videos, then we're going to equal them. And negative x plus 2x will give you x, and 400 subtract 250. Okay, so that should be 150 there. So x is 150, and let's use this 150 in one of them. Let's say the number 1. All right, so now that x is 150, you need to find y. So let's go to 1, y equal negative 150 plus 250 equal 100. All right, now we know these, so we can start comparing. This is the goal. This objective function is 50x plus 40y. So for here, that's 40 times 250. That's 10,000. All right, so let's get this one. For this one, same. It's 50 times 200. That's also 10,000. And now the next one, it'll be 50 times 150 plus 40 times 100. It's 11,500. All right, and that looks like the winner, right, for maximizing. Because that's the goal. And so as you see the answers, we found 150 and we found 100 already. And now the maximum profit, which is this 11,500. And the question here explains that it's given in cents or pennies, right? So we need to convert this to dollars. In order to convert it to dollars, we're going to divide by 100. So 11,500 divided by 100 will give us 115. All right. So when you use this equation for the objective function there, it's in cents or pennies. So you need to divide by 100 to get the answer there. Then you'll have different equations that you need to solve and find. And this is, so you need to watch the previous video, then you get y by itself, for example, for this linear programming problem. So for example, if we take this one to get y by itself, we're going to have this, and therefore this one, you're going to subtract x, then you divide by 2, so this is going to be 4, 8 by 2, and this is just x, and this is y. So these are the constraints, right? And this is the objective function, and we need to minimize. So remember, we are not always maximizing. Sometimes you want to minimize. Depends on what application you're working on. So one method is you follow what we did in that video, and you graph, then you cross out the other side, you graph, you cross out the other side until you find the feasible set. But here I'll take a shortcut on it and explain another way. So let's look at this line. If I want to graph this line, which you will need, of course, in the other method as well, you're going to go to 10. Right? Then we're going to come down 2 and over 1. And it's going to be some type of line going from left to right. And it's going to cross the x-axis. Because it's going to cross the x-axis, let's find the x-intercept. What is that x-intercept? X-intercept is where y is 0. So you subtract 10, divide by -2, and it should be 5. So 1, 2, 3, 4, 5. So it's going to be this line. That's the first one. Let's do the same thing to the second one. It's going to be 1, 2, 3, 4. And it looks like it's going to cross it, right? So it's going to be -x over 2 plus 4. So x equal, you subtract 4, you get -4. You multiply by -2, and you'll get 8. So 8. So you can get that one. For x is greater than 0, of course, x is greater than 0 is this right side, so you cross out the left. Y is greater than or equal 0. So it's the top part, so you cross out the bottom part, which means we're interested in this lower part. And that makes what we're interested in all right, so we have these, right? So let's look at this one here. And we already said that this is a 10. So this is a 0. And this is, we're not interested in that one, but we're interested in this new one here. And we're interested in this furthest one is 8. All right, so we need to find this vertex here. I just used that to graph. And since this vertex is the intersection of these two lines, that means it satisfies these two lines. So we need to equal them because they're already y and y equal. So if you equal them, you'll get one of the variables. I have a 2. So we can, let's get rid of the 4 first. By subtracting a 4, you get a 6. And from here, if you can do any way you like. Let's say if you don't want, you can add the x and bring the 6, you know. Something like this. You can do common denominators, or you can just multiply by 2 everything. Then you get -4x plus x equal -12, and you don't have any more. And -3x equal -12, and x equal 4. So this is a 4. And we can go back to any line. We need to find y. So we can go back to any line, 1 or 2. Let's say Remember, these others are X. Let's say these are here, right? So they're not these two. We're talking about this vertex, so it has to do with 1 and 2. Constraints 1 and 2. So let's say we go to 1. It's 1 equal negative 2 times 4, and negative 8 plus 10 equal 2. All right, and 42. All right, so now we are ready to figure out to minimize, and the objective function is 4x plus 3y. Let's write it here. So 4x plus 3y with this 0, 10 is 30, right? With this one is 32. With this one, it's 4 times x, which is 4 times 4 plus 3 times 2, which is 16, right? Plus 6, which is 22. So 22 is the winner here. That's where it's minimized. That's the minimum. 22 is less than 30 and less than 32. So the minimum value of the function is 22, and that happens at 42 values. All right, thank you.